Okay, so let's look at chapter 7. Water quantity and quality. I'll go through the most important slides. Let's look at what is the meaning of water footprint. So that came in one of my multiple choice before. Determines the water required to support human activities. Of course, you could see the footprint for some countries, and you could compare which one has a greater effect affecting the world with high pollution. So let's look for more slides that we'll be using in the final. This is also an example of how to design. Of course, you want to estimate the daily and yearly water demand. So this is one of the definitions too that came, or one of the examples came in one of the finals to find out how many gallons per year. So this is a good example. Also, now there is the underground, there is either water distribution system or wastewater distribution system, not collection system, sorry. So we should know that A to the left, it's a loop system. This is for water distribution. B, the branch system. This is for typical wastewater collection. Collection to the wastewater. And this is distribution from the Ministry of Water and Electricity. So this is for river water quality. DO saturation, KH Henry law times the pressure of oxygen. So try to know what is a SAC curve, DO SAC curve. So try to understand the parameters: initial deficit, DO minimum, deficit, saturation DO, and dissolved oxygen from the bottom, XC and TC. This is a very important example. Please redo this. Okay. The oxygen deficit that we need, that deficit is DO sat minus DO actual. You need it for here. Now we're going to come to the equation that we will be using in the exam for sure. Deficit at any time t is equal K1 L naught over K2 minus K1 times e to the power minus K1t minus e to the power minus K2t initial deficit times e to the power minus K2t. This will be given in the exam. You don't have to memorize it. This is the same. But this is now at any distance. This is d at any time. Of course, if you put distance, you have to change the time to distance over velocity. Now, you could find, you don't have to do the derivation. This equation will be given to you. T critical, the time to reach critical is this equation. This is a very important example. Read this example and see if there is any problems. This is important. Okay, so I think we are done from chapter 7. Now we're going to go to chapter 8. Okay, chapter 7 is done. Let's go to chapter 8. Okay, what is chapter 8? Water treatment. What we have to treat water. Of course, the water that your faucet is being treated. We provide potable water that is potable. What is potable and what is potable? Very important two definitions. Okay, let's look at the things that we need to know. Turbidity. Turbidity, the units is NTU. NTU. Okay, particles, color, categorized as apparent or true color. So let's go ahead and look for more important things for the chapter here. pathogens. Okay, these are the units. These are the processes that remove a significant amount of raw water constituent. So if you have bad water, that's for drinking, we could use turbidity and particle removal using coagulation, flocculation, sedimentation, granule filtration. You could remove major dissolved inorganic by softening, aeration, membranes. You could remove minor dissolved inorganic by membrane. You could remove pathogens using sedimentation, filtration, and disinfection. Major dissolved organic, membrane, and absorption. Try to understand each constituent, and I will bring something like this in the final. So you have to know exactly. You can't just say disinfection to remove turbidity. It might remove oxidize some, but turbidity and particles, how could you remove them? By coagulation, flocculation, sedimentation, and filtration. This is coagulation, flocculation. Of course, no, don't worry about it now. Even though that I was thinking that, that's gonna come. What is coagulation? Of course, coagulation and flocculation are together. Coagulation is charge neutralization. Flocculation is what? Aggregation. Once you do charge neutralization, now the aggregates will destabilize, and then they will settle. Of course, we use coagulant chemicals to destabilize the particles, and one of them is alum. So you can see these are the coagulant type, and sometimes we add aid. The jar test is what? It's to screen the type of coagulant and the proper coagulant dosage. So a jar test, we don't do it for disinfection, we do it for what? For coagulation testing. If you plot alum dose in the x-axis from the jar test and turbidity NTU in the y-axis, you can see a curve like this. We choose the lower turbidity value here, and this would give you the alum dose here. Okay. You don't have to worry about this. Really? Oh, hardness removal. Sedimentation. For sedimentation, we studied only the discrete particle settling. What is discrete settling? No interference when the particles are settling with each other. Okay? Try to understand what is discrete settling. Oh. Also, for discrete settling, we use Stokes law. So this is the Stokes law, settling velocity. And we have to check if the flow is laminar. If it's less than less than or equal to 1, now this is applicable. If it's not, then we have to use Newton's law by finding the CD. So this is an example. This is a very important example to check for applying Newton's law when the check with the flow was not laminar. So you could check here. They check Reynolds number. It was less than 1. Nice. So you could apply Stokes law. So this settling velocity is applicable. While here, he found settling velocity, and then when he did Reynolds number, this is higher than 1. So which means that this is not applicable. Now we have to find the real settling velocity. So we go and apply Newton's law, CD, and settling velocity, 97.1. And then you go and initially it was 97.1, and you go and do the iteration until you get to the point where the numbers are the same. So this is going to be the actual settling velocity, 86.5 meter per hour. Okay, so now we come to the critical velocity. When we are using this, the critical velocity and the overflow rate is equal depth over detention time. Detention time is volume over Q. We could use any of these equations. And also the volume is H naught times A, H naught with H naught, Q over A. So the two important equation for overflow is either Q over A, I'm going to put overflow, or H naught over theta. This is also if you want to know how much is removed by dividing settling velocity over the overflow rate times 100 to find out 20% is removed, 90% is removed, how much is removed. This example is very good to look at. This other type, don't worry about the other types. You will study it in the master if you want to do your master's in environmental engineering. So filtration, and of course, I don't think there is anything else in this filtration. Disinfection. Pathogens can either removed by treatment, process such as granular filtration, or inactivated by disinfection agent. So disinfection is the inactivation of microorganisms or pathogenic bacteria. The two terms of disinfection, either primary or secondary disinfection. Try to understand the meaning of these two. There's a lot of disinfection processes, but this equation is very important. Let's go to, well, this is from the, I think from when I was teaching. Let's go back. Okay. It's ln n over n naught minus k t. N is the concentration of the concentration of the microorganisms at time t. Let's call it ln nt. And L naught is the initial number of microorganisms. Let's say, as I gave you in the class, let's say that this is like 1 million. Initially, the number of microorganisms was 1 million. Whatever that was, that microorganism, Streptococcus, Cryptosporidium, whatever, okay? And it goes to 2, from 1 million to 2. Now we are applying disinfection agent. Of course, the disinfection will kill it from 1 million to 2. But we have K, constant that comes with disinfection agent, and we need to know the time. The time it will take to kill 1 million to 2 microorganisms numbers. CT approach is also another example. It's viewed as a dosage disinfectant, CT approach. Concentration versus the time. The time it's taking the disinfectant to stay inside the reactor. Well, now this reactor is called what? It's called contactor. And you can see from here, once you do the CT for each disinfectant, they are variable. Each disinfectant has a capability of inactivating a certain amount of microorganisms. Look at UV light. UV light doesn't have a CT, that has IT because it's radiation. So this is the range, how much small range of IT for UV light. Look at this example, and of course membrane process. And this is, I think, all done. Okay. Absorption, we know activated carbon. And I don't think there's anything important now. Let's go to chapter 9. Okay. Now, chapter 9, wastewater and stormwater collection, treatment, and resource recovery. What is wastewater? We did discuss this, and this might come again, and maybe this came in the quiz, but what is the purpose? Why we have to deal with treating wastewater? Well, protecting human health is number one, and prevent of pollution to the receiving surface water or groundwater. There's a lot of measurement. We did COD, we did BOD, TSS, nitrogen, phosphorus, NH3. There is visual pollution and odor. There's a lot of factors, and of course, bacteria and viruses. Oh. There is steps, and this keep coming every final. Of course, it came last semester in my second exam because that was part of second exam, but now it's part of the final. You have to know the steps. Wastewater treatment steps. Oh, really? Okay. You have to know how to rearrange this. Initially, it's pre-treatment. Okay. And then it's primary treatment, and then secondary treatment, and then tertiary treatment, and then disinfection. This is the procedure. Step 1, step 2, step 3. Wastewater has to go through all these steps. Okay, so let's go. Initially, we do a preliminary treatment. That's initially with the wastewater into the plants. Initially, it goes through this. It's preparing the wastewater for further treatment, removing oily scum, floating debris, grit, everything from the wastewater before it goes to the units. Screening is number one, bar screen. This is an example of bar screen. Grit chamber. Grit chamber is like a tank. All the grit will be settled at quiescent condition, and the specific gravity of these particles should be 2.65 and of course higher. Sometimes we have aerated grit. And these are the design information used for aerated grit chambers. This example came in, I guess, final last year. So read this example very carefully, because this is to design an aerated grit chamber. From the design table you have at the top. Flotation, equalization. Now, we come to the next important process, primary treatment, is to remove solids through quiescent gravity settling. The other one was grit removal. Now here, you are removing solids through quiet again and gravity settling. Here we have 2 hours of settling. So let's size. This is how to size it. Find the diameter and find the depth and everything else, and check the overflow rate. You don't have to check later on after the flow rate. If you need only detention time, just find it and that's it. Again, our exam will be multiple choice. Secondary treatment. This is the main process in the wastewater treatment. The microorganism will be from here. Okay? Of course, we are studying suspended growth. There is other ways, but for us, even for Kuwait, they are using suspended growth reactors, and we call it activated sludge. Let's look at the process that is important to look at. Now, we have to know how to design this, because this comes every final, designing an activated sludge system. Okay. The influence comes from the primary clarifier. Comes to the aeration basin. We have volume, we have X microorganisms, we have substrate. This is the aeration basin. This is the secondary clarifier. And this is recycled back from the secondary clarifier back. This is the return activated sludge, RAS. And this is how much will be wasted. waste activated sludge. Effluent to disinfection. Okay, so we have to know this equation, SRT, the relationship between SRT. If you increase SRT, what will happen to the volume? Increase. If it's by themselves. Later, if this is not N controlled, X will increase if SRT increase. What will happen to QW, XW together? If SRT increase, this will decrease. This is an important equation, and this will be given to you. Okay, you have to understand this example. Very important example. This example is very important. Of course, for every reactor, there is a solid rotation time minimum. You cannot go below. So you have to understand this equation. So now we come to a very important concept, food over microorganism ratio. We close the door. Food over microorganism ratio is, as mentioned in class, it's S naught, substrate initial, times flow rate initial over XV. Okay? As we mentioned here, this is volume. This is volume. What is? This is volume and this is Q. So volume over Q is detention time. So you don't have to be confused if you see it this way or this way. They all mean the same thing. It is initial substrate over microorganism inside the aeration tank divided by detention time. Detention time is volume over Q. Okay, so this is an example of finding the F. This came also in one of the multiple choice. I gave them the flow, I gave them the substrate, I gave them the biomass concentration in the aeration tank, and I gave them the volume. I just want them to find F over M. So if this equation, we know how to do it easy. Okay, that's another example of F over M. Okay, so we are done from this chapter. Now we'll go to chapter 10. Chapter 10. What is solid waste? This is a big problem in Kuwait. Big, huge problem in the Middle East. Okay? Of course, there is a lot of solid waste here in Kuwait. We have a lot of paper, plastic, we have ash, we have cafeteria food waste. We have also food. We should put from home, food also from home. Leaves and cut grass from barks, hospital medical waste, very dangerous. Demolition and debris from the construction site. This is a lot of solid waste. Okay, so remember I gave you this in the quiz, and you have, I might give you back. I still think that people does not know how to read the table. If I tell you which location has a high food waste disposal in solid waste, of course you would see India, Bangalore. If I see which, could you arrange the country from highest rate of paper waste to lowest city of paper waste? You can see that number one is what? Bogota, Colombia, in paper. Number two is what? Manila, Philippines. Number three is what? Paraguay, and then Mexico City, and then Bangalore. So you should read the table very carefully. You don't have to, it's not difficult. Reading the table is very, very easy. If I ask you, for example, Which city has the lowest generation rate in general? Generation rate of not of everything, all solid waste. You can see here, Bangalore, India, and Manila, Philippines has the lowest, 0.146, and 0.146 for Manila. And you can see Bogota, Colombia has a higher generation rate, 0.27 mega gram per person per year. This also came to the quiz. This is very easy, very easy. Please look at this again. Of course, solid waste is being characterized by the following items. Know it for definitions. Solid waste, not all of it is solid waste. Some of the solid waste is hazardous. So if it is hazardous, now it cannot be called solid waste. If it's ignitable, if it's corrosive, reactive, toxic, radioactive, if it's infectious, any of these characteristics, now this waste will not be called solid waste. It will be called hazardous waste. This came in the quiz, and I think most of you solved it. The resin types and what type of bottles and what type of plastics. Composting will come in the final. What is composting? What is the objective of composting? What common types of composting? And this. Now, let's say if we have activated sludge, what's the nitrogen percent by dry mass is 5%. C over N is 6. This example is very important. Again, remember in your notes, this is not times, this is equal here. Okay, this is 0.08 times X. This is a typing error from the book. It's not my error, it's the book error. So again, this is very important. Okay, I think we are done on this chapter and we'll go to chapter 11. Air quality issues and technologies. Okay, chemicals that might come to human and human could breathe it is toxic chemicals, potentially fatal, harmful to lungs, causing cancers. Of course, why we are doing air pollution and why we are treating it, and why we have to have, of course, clean air is very important to humans and animals and plants. Also, we have to understand there's something called indoor that's related to personal, and there's something outdoor air that's related to ambient air quality. Criteria pollutant, carbon monoxide, nitrogen dioxide, ozone, sulfur dioxide, particulate matter, lead. It came in my final one time in a definition that PM10, particulate matter less than or equal 10 micrometer in size of particles. PM 2.5, particulate matter less than 2.5 microns particle diameter. This example is very important. Please, again and again and again, read this example. Try to solve it. If you have any problem, please message me, okay? Now for the models, we will go, again, I don't want to be into more into air pollution, but this equation is very important. This is how to check the air pollution movement from the chimney to the other locations. The two examples that I want you to study. Remember, it's the height of the chimney, and this is a question and the final. H and delta H, the bloom height, and then the big H, the small h with delta H. And this is also, it depends on daytime isolation. If I give it to you in the example, and is it strong, moderate, or slight? And of course, you could find out the stability. Let's say if the wind speed was 7, so it's like in 7 meters per second, you could see if it is slight daytime isolation, you could find selection D. If it's nighttime, you could select also D. So it's all D for higher than 7. And then from that class, stability class, you could go here. Are we in urban condition? Or we are in the desert, open country, or in the farm, Al-Abdali or Wafra, or urban condition in your house, Yarmouk, Khaldiya, whatever close by. Okay, so from this, you could find this. If it's, let's say that we are in Khaldiya. Okay, so D, this is sigma Y in meter, and this is sigma Z. Okay, so X is the distance because you want to find out the pollution at the time, at the distance X. You could do this, but as long as you do it with the other one, it's very fine. Don't worry about grand friction equation because that's not an important for now. Let's concentrate on this example. This is very important. And of course, this is also very important. This example, don't worry about it. Okay. So hopefully that this is good summarization of the revision to the final. And I think if you follow up with the YouTube homeworks, and if you follow up with the quizzes and my revision now, you will get more than 90%. You will be fine, just fine. So please have fun and enjoy studying, and you will be in good shape as long as you are organizing your time and studying. We'll see you on Thursday at 8 o'clock.